range. There you go. So I don't know how to pronounce it the actual way, right? Anyway, so range, again, that's the maximum minus the minimum, right? That's the difference between the highest and the lowest value. That's the most basic way of getting the measure of the variation, okay? The next one, standard deviation, right? And let's see later how we're gonna use standard deviation and how it describes the dispersion or variability of our data, okay? Next one is the variance, and as you may notice, all of these are talking about what? Raw data. Okay, guys. Next one, we're gonna use the empirical rule, and I think tomorrow will be another day to deal with Chebyshev inequality. Okay, so first of all, what are the formulas for such? Once again, the range is maximum minus minimum, right? The standard deviation, we have the formula for standard deviation. The first one, so as you may notice, they're basically the same formula. It's just that the population standard deviation uses the population size. However, the sample standard deviation uses what? N minus 1. So whatever your sample size is, you less 1 from it. Why? Simply because theoretically, you always have 1 less degree of freedom on a sample size. Okay, so that's why we always have a minus 1 in there. Always 1 less degree of freedom, right? And the last one is, whether that be a standard or deviation population or sample, you just square that value, then it's gonna talk about range. Well, not range, variance. Okay, so let's now use these to analyze a certain raw data in here. So if you go to StatCrunch and go to what is this? 3.2-20. All right. So if you just want to explore on this data, we have the following, right? This is traditional and flipped. Okay, so that's traditional, that's flipped. Now, how we're gonna get the measures of dispersion for such? So once again, this is what we're gonna do. What did we do last time? We go to stats, we go to summary statistics, okay? We're gonna go to what? Columns, right? There we go. And then from columns in here, I'm gonna select those two because we want to compare the traditional and the flipped methods, right? Learning methods in here. And we're going to consider the following measures of dispersion. First one will be what? Variance. Okay, so here I'm going to click variance. Also, I'm going to click what? Hold the control, click standard deviation. Right, there we go. If you scroll down, we got a range. You see that range? Okay. And also, we're going to click on the minimum and maximum. See the relationship between range, minimum, and maximum, right? So once again, those are the numbers that we click, okay? Variance, standard deviation, range, minimum, and maximum values, all right? And again, I use this one for both the traditional and flipped learning methods, all right, or teaching techniques. Now, let's go ahead and click compute, okay? Now, what do we see from here? So here it is, the data set. And here it is, okay? Now, what can you see from here? Okay. So first of all, based from range, which one has a more dispersion? Based on range, which one has more dispersion, guys? So look at the range. Which one is more dispersed? The flip or the traditional? The traditional, very good, right? So that's correct, Mason. As you may notice in here, the range for traditional, right, let's call it T, is more than the range for the flipped, right? And with that being said, then that means according to the range, traditional is more dispersed in terms of data set. Are we good? It's more spread out. Are we good? Right. Now let's see. What is the relationship between max, min, and range? Let's see. what do you do with these two to get the range? Is it true that 85.3 minus 56.2 is the 29.1? Right? But let's check it out, right? So what's that? Let's go to our decimals and plug it in there, right? So just to verify, okay, here we go. What's the minimum again? 56.2, thank you, 56.2. Minus, what's the minimum?
Oh, sorry, the maximum was 85.3.
Okay, 85.3 minus 56.2. Did we get the 29.1 on the range? Let's see if we got it right. Where's our data set? Here, okay. Did we get 29.1? Yes, we did. Alright, so again, range is what? Maximum minus minimum. Good. So the difference between the highest and the lowest value, that's the range. So that's the first, the most basic of all measures of dispersion. Are we good? Right. Now let's see. According to standard deviation, which one is more dispersed? Traditional or flipped according to standard deviation?
Traditional?
Traditional as well, right? Very good. Obi, as you may notice in here, the SD, let's call it SD for standard deviation, for traditional is more than the standard deviation for flip, right? So that means the traditional method has more dispersed data. Are we good, guys? Right? And the last one is, according to the variance, is it 78.08? So what do we do with the standard deviation to get the variance again? We said a while ago. Yeah, you square the standard deviation, and we're gonna get that variance in here, right? So let's put it in here, right? What's that? 8 point, let's see, can I copy this one? Okay, we try copying this one. Put it in decimals, okay, and then squaring it. Yep, squaring it, okay. Do you get the same, 78.08? So if I go back in there, yes, 78.08. Are we good, guys? So once again, that verifies that whatever your standard deviation is, you just square it, you're gonna get the variance. Are we good? Right? So going back in here, according to the variance, right? So I'm gonna color it purple. According to the variance, so noticing in here, which one has more variance or more dispersed according to variance? Traditional or flipped? Still traditional, right? So as you may notice in there, the variance of traditional is more than the variance of the flip. So in summary, right, we can say that what? Traditional method is more what? Dispersed, right? Or spread out in terms of this data set than flipped method. We get? So once again, measures of dispersion talks about what? How dispersed your data set is. Whether we use, once again, range, standard deviation, or variance. Any questions regarding that one, guys? Okay. Now, let's talk about this next problem in here and see how we can compute for measures of dispersion for such as well. Okay, so here it is. Okay, here it is. Okay, let me X this out. Okay, let's read this one in here. Table 8. Okay, 3, go ahead please. Yeah. Computing the range of a data set. The data in table 8, see that in yellow?
Yes, for students. Like a problem, okay. Computing the range of a set of data. Problem, the data in table 8 represents the scores on the first exam of test students and goes introductory statistics to keep the range. Approach. The range is the difference between the largest and the smallest data values.
Thank you. All right. So once again, first of all, is this a population or a sample. Again, these are what? These are the first exam scores of 10 students enrolled in introductory statistics. So is it population or sample?
Sample.
It's basically a population, right? Simply because these are all the students on that introductory class, right? We didn't do a random sample of the population, right? We basically get the entire list of students on that introductory class.
So there's only 10.
So there's only 10 students, right? Did it say there's only 10 students in here, right? Yeah. Example of 10 students enrolled in introductory statistics, right? Are we good, guys? Right? So since we didn't do random sampling from a population, then we can assume, and then we can also state, it is also implied that this is what we call the population size, right? And what is the population size? 10. Are we good, guys? Right? So big N is 10. Get it, guys? All right. Now, how to get the range? Once again, largest and smallest data values, right? So what do you think is the max and min for such? All right. So check it out, guys. Kalina, what do you think? Max and min. It's the highest and the lowest.
The maximum is going to be 94.
94, just it. Right? So that's correct. Very good. So, I don't think. There we go. Let me highlight them. Okay. So Justin is the highest. That's the max.
And then
Who is the lowest for such?
Jennifer.
62. Yep. There we go. Okay. Max and min. So basically the range will be basically the difference of those two values. Alright, thank you for that. Okay, so range is equal to
32.
yep, 94. There you go. Minus 62. Yes, Obi, what you got?
I thought it was 32.
32. Right? Got it, guys? There we go. Any question regarding that one? Right? So that's the range, right? What the basic of the measures of dispersion, right? Now, how do we do this? By decimals this time, right? We're gonna get standard deviation and variance by decimals, right? So here this is what we're gonna do. Ready, guys? So let's go to decimals. Okay. So first of all, we're gonna create a data set. Those are students, right? Let's call this S equals students, right? Let's put in the data set. Trey, can you tell me what scores there are of the 10 students? Start with Michelle. 82, comma. What's next? 77, 90, 71,
62,
62,
68,
68,
74,
74,
84,
84,
94,
94,
and 88.
88. Alright. So as you may notice, we have 10 on the elemental list. Are we good, guys? Alright. So let me just erase this one in here. Now, let us see what measures of dispersion is possible on our calculator, right? So if you go to functions, you scroll down, you would see what? The following, alright? There's two STDev, right? So when you say STDev, that's the sample standard deviation. But you talk about STDev P, then that is the what? Population standard deviation. So these are two different standard deviation depending on the given. If it's a population, STDev P. If it's sample standard deviation, then use STDev. Get it? Okay. Next one, variance. Get it? Yeah. Honestly, in here, the variance is basically the population variance. Okay. Next one, what else do we need? You can get the maximum and the minimum as well, right? To get the range. Are we good, guys? Right? So let's see how we're gonna do this one. Well, first of all, can we get the maximum in here? What's the maximum of S? 94. Good, right? What's the minimum of S? Okay, oops. So by the way, it's case sensitive, right? You notice that one's case sensitive. 62, very good, right? So with that, what's the range, by the way? What do you do with 94 and 62? Subtract them, right? Did we get 32 a while ago? We did, right? So we're good with the range, right? Next one. This is a population size, all right? So what do you put? ST dev P, that's population standard deviation. Parenthesis, what's that? Of S. Again, I just, this S is variable, all right? So you can make it P, L, Z, whatever you wanna name it with, right? I just put S for students, S for statistics. Are we good? F for scores as well. We good? So again, no matter what letter you put in there, please do. Are we good? Right. So again, that's the population standard deviation. Without the P, that's the sample standard deviation. We good? And the last one is what? Variance. So what's how to get the variance, by the way? Var. Okay. Again, it's case sensitive. I put in big S, so I put. Are we good, guys? All right. So those are the different measures of dispersion for our 10 students a while ago enrolled in statistics class, right? What's the standard deviation? 9.8, right? So that means the gap from the mean is what? 9.8, right? Yeah, should that have been like a normal distribution like such, okay? And the last one is a variance, right? The variance is how much? If you square this, then we are assuming that that will be 107.11. Dot, dot, dot. Are we good? Questions, guys, with those measures of dispersion? And again, we are trying to compare one data set from another based from this. The bigger your measure of central measure of dispersion is, the more spread your data is. Are we good? The smaller the value is of the standard deviation, range, or variance, the tighter your data set is. Are we good? Questions, guys? And the last one. Let us now analyze this one in here based from its shape. Okay, so here it is. Okay, let's read this one. We are given a histogram and see how we can analyze this data set. Okay, Abigail, let's go ahead. Let's read this one. Which histogram?
Histogram detects a higher standard deviation. Justify it.
Thank you, right? So, which of these detects a bigger standard deviation? Right? So what do we notice in here? Well, first of all, it talks about standard deviation, right? However, we know that when you talk about standard deviation, it's also related to what? Related to other measures of variation, like what? Like range and also variance, right? Okay, so they're all related. Okay, so in short, the higher the range is, the higher is also your standard deviation. The higher your variance is, the same is happening to your standard deviation, right? So with this being said, you might be asking, Mr. Deal, there's no formula that's given, there's no values that's given. So how do we compute for the higher standard deviation without the numbers, right? So in here, we basically just observe the data set, right? So in here, what do you think is the best, easiest way for us to measure dispersion? Range, standard deviation, or variance? Range, right? Because as you may notice in here, the only thing that we can get is the what? The maximum and the minimum, right? So for example, for data set A, what's your maximum? 60, right? What's your minimum? 40, right? So with that being said, then we can use that one in there, right? So in this case, what's the range in here? For data set A, right? 60 minus 40, right? So that's what? 20. Okay, right? What about the range for data set B? All right. Anyone can tell us what do you think the range is? Brett, what do you think is the range for data set B in this case? So first, what's the maximum?
75.
75, very good. Right. What's the minimum? 30. Alright, so with that being said, what do you think will be the best analysis for our range for such?
45.
45. So with that being said, thank you, Brett. With that being said, once again, since range, variance, and standard deviation are related, even without knowing what the value of standard deviation is, what do you think would be the data set that will give us a bigger standard deviation? A or B? B. Very good, right? Thank you. So again, in here, since we know range, variance, and standard deviation are related, even if you just get the range, then that means the bigger the range is, we can assume that its standard deviation is the bigger as well. How we get?
So all three are related. That the higher
All
the range,
three are related.
the
Very
higher the
good.
deviation, the higher the variance.
Very good. That is correct, right? And so we notice that's also reflected on our first, the stat crunch a while ago, right? We have mentioned the relationship between, the comparison between traditional and flip, right? And as you may notice, it's consistent that range, standard deviation, and variance are related. Are we good? And again, the bigger these values of dispersion or measures of dispersion are, the more spread your data set is. We good? And when you say the more spread your data set is, the less precise your measurements are, right? Because it's like all over the place, right? Scattered. But the lesser your standard deviation or measure of dispersion is, the more precise your instrument or your values are, right? They're consistent, right? When you say precise, they're more consistent. Less precise, more precise, that means more consistent. Are we good? Got it? Okay. Meaning the values are close to each other, right? Now, how is this related to our empirical rule? So as you may notice in here in our empirical rule, this only applies to a bell-shaped symmetric distribution, okay? Now, for example, in here, that's the mean, right? Now, if you are talking about from the mean, one standard deviation above and below the mean, that is what? 68% of your data is in there, right? Next, if you are talking about two standard deviations above the mean and below the mean, then that range, set of values in here will comprise what? 95% of the entire data, right? And the last one is, if you are talking about three standard deviation above and below, then that talks about what? 99.7 of our data set. Are we good, guys? Right? Now, let's talk about this one, right? Assuming, okay, again, in here, we have the assumption, for example, that our data set in here, on the 10 students, let's assume that that is a normal distribution, right? So with that being said, let's compute for the what? What do we need again? The mean and the standard deviation, right? So how do you get the mean in here again? MEAN, right? Of S, right? Oops. So once again, our mean is how much? 79, and our standard deviation is 81. 9.81. Are we good, guys? Now, hold on to your decimals. We're gonna draw, right, a normal distribution according to this data set, right? Again, assuming that this is a normal distribution, right? So here's what you're gonna do. Ready, guys? Put in the following: normal dist. That means normal distribution. Okay, right? Put in normal dist, and then after that, put parentheses. Okay. Now, what do you see on the parentheses? It says in there, it needs two numbers. It needs the mean, comma, and the SD, or standard deviation, right? So once again, what's our mean? 79. Comma, what's our standard deviation? Well, we can round it off to the nearest tenths place for now, right? Just for convenience, 9.8, okay? So again, once you type in normal dist, it's gonna ask for two values from you. The mean, comma, standard deviation, right? It will also tell you, in most problems, it will tell you how many decimal places you're gonna round it off, right? In here, it doesn't say, so let's assume tenths place. Are we good? One decimal place. Now, where is our data set? Okay, so here it is. Ready, guys? I'm gonna go to graph settings, okay? Now you see this x-axis? I'm gonna put in there what? 3 standard deviations below the mean and 3 standard deviations above the mean, right? So in here, what I'm gonna put in here on the minimum is what? What's the mean again? 79, are we good? Minus 3 parentheses or times, what's your standard deviation again? 9.8. Are we good? Right, so again, on the minimum, I put what? 3 standard deviations less than the mean, right? So your mean is what? 79 minus 3 times 9.8, okay? Are we good? On the maximum, I'm gonna do the same. 79 plus 3 standard deviations, right? What's the standard deviation again? 9.8, right? Are we good? Right. Now, you see this y-axis? We're talking about relative frequency. So, always less than 1. So, I would put in here from 0 to 1, all right? And then I can, as you may notice, the curve in here is just so small. So, you can lessen the 1, because we know it's less than 1 anyways, right? I can do 0.5 or something less than that, 0.01, let's see. Oops, okay, it's too much. Okay, 0.03 will be fine. Okay, 0.05 will be fine, right? Here we go, right? So that gives us our data set, okay? So we notice in there, right? So what do we notice on this data set in here, right? So here it is. Where is the mean once again? X equals what? 70 what? 79, right? You see the 79 is at the middle, right? Okay. Next one, I'm gonna put in here the first one. 79 plus what? 1 standard deviation above. Are we good? Right. Okay. I'm gonna do the same in here. 79 minus 2, minus 1 standard deviations below as well, right? Are we good? So as you may notice in here, what is that value? So if I go in here, if I click on CDF, I put on the minimum what? 79 minus 9.8, and in here I'm gonna put what? 79 plus 9.8, right? That means what? 1 standard deviation below and 1 standard deviation above. The mean, which is 79, what did you notice about the percentage, the relative frequency? 0.68. That means what? 68% of the entire data falls within this interval, right? From where to where? From 79 minus 9.8 and 79 plus 9.8. And how much? 68% of the data set falls in there. Again, assuming that it is a normal distribution, okay? Right? So we're gonna analyze this one tomorrow some more, all right? Because that's basically the, the culmination of the mean and the standard deviation and how it applies to your data set. Where do these values fall on your normal distribution? Again, assuming that it's normal distribution, right? Okay. Thank you guys. Any questions regarding that one? Again,